So in this video we are to show you the basic example to start importing the GPS data for the co-registration. Is essentially to make a transformation from the APS-G in Gauss-Braga, in this case, to UTM, and we are show you a basic demonstration, also improve integrate the QGIS with essentially Python code that permitting you to check a clear example of how physical co-registration with GPS point relief works, and how this GPS point is very important and familiar to reduce and maximize the effect of co-registration of a single parcel. And why is it so important? It's so important because through this method essentially the co-registration permitted to maintain the same area and don't alterate the value of parcel area. That is the real facts of important in cadastral mapping. So we can use basically some tools. We can check on plugin. We have the ArcGIS surveys, and for example, with ArcGIS survey you can use collected the data directly from Google Earth using and integrating PostGIS or PostgreSQL, or in a simply way you can use the GPX segment important, that is an assistance, or this is another tool that is called batch GPS important. Is very familiar because allow us to import all GPX file from GPS. You can install easily that, and through this you can go on this and starting importing this point. So this point is very essential because was centered from this central point, that is the physical central point of this parcel, and they permitted to make the co-registration, the transformation of positioning of this parcel to from Gauss-Braga to UTM global coordinate system. I show you the basic code that can permit us to verify the free positioning, the free translation positioning of this free parcel. So the first parcel is have this positioning of centroid. In this case we are applying a module that permitted to avoid the stretching of area. So the GPS point measured with in this case we have 4 points for this parcel, but you can make much more point, but so the minimum point is 4. Is essential to have the centroid of parcel and other points. So the co-registration works through a high force translation, starting by the positioning of the centroid that it remains. You can do the drag and drop of parcel, but you need to put that and move to new position. So you are essentially make the translation of centroid, and after the co-registration works through the adjustment and the rotation of this parcel. So if you go for the first example, is the first step in the co-registration. When the code works, it makes this with this new code. It put the centroid in correct position, and after they apply the rotation, the translation, so but they don't make any deformation of the area. So in this model you make a comparison final between the area in the Gauss and area line in area in rigid line, and so the difference in this case is very less. Sometimes is minus than previous, but is very near to zero. So the method is the best in this moment that permitted to verify the correct position and check the translation in a correct way. Is essentially based on differential mathematical equation applied to the centroid and consider the parcel as like rigid corpse. So this transformation is made by the roto translation, and we are checking also the numerical stability of the position of this. In this way you can use I will create this also for so this is the basic script that you can use and test on your own, and that I leave you in the description in the repository to make the co-registration using 4 vertex relief with GPS and the centroid that is essential. So for questions you can write me on chat. Thanks for attention.